Okay, here we go. Let's do the examples. I hope you had a nice couple-minute break there. So let's do some examples. I want to find rotational symmetry, and I want to then describe the rotations. All right, I think I'll maybe do 2 of these here, and then you can do the other one. That'll be nice. Good idea. So let's look at this rhombus. If I wanted to take this rhombus, and I wanted to rotate it around some number of degrees, I'm not sure how many, I want to know when would it land on itself. So when could I take this rhombus and it would kind of end up on itself here. And I think that if I rotated this point here on the end, and I took it and I kind of grabbed the rhombus by this point, and I grabbed it and I rotated it and spun it right around the center, right? And I spun it and spun it and spun it and spun it and spun it, and I did it 180 degrees. I think that that rhombus would end up back on itself. And if you don't believe me, cut out a rhombus, spin it 180 degrees, and see if it's right. But I think that that's going to end up at end up back on itself. So this would be one rotation, and it's 180 degree rotation. One 180 degree rotation. I'm going to save that beautiful octagon for you to do. Now remember, all these sides are supposed to be congruent, so I know they don't look like they are, but all those sides are supposed to be congruent. So go ahead, figure out the rotations and how many rotations we've got. And then, now this right triangle, let's think about this triangle. We could find the center of the triangle, maybe. Well, not really. You learn geometry, that's kind of, there's lots of different centers, right? Depending on what we call it. But maybe we could find the centroid, that'd be kind of the center of balance. And if we spun it around, we could try and find a place where we would end up back on itself, but I don't think there's a place until we get back to the beginning, if we kind of use this as the center. In fact, I don't think there's any way we can do it. So hopefully you can see that this is none. None at all. You can do that octagon on your own, like I said. You know, but that doesn't mean that all triangles wouldn't. For instance, if I had an equilateral triangle, I think we could probably find some rotational symmetry in that. But for right triangle, we're pretty much toast. And even an obtuse or an acute triangle, depending on what it looks like, we're probably not going to be able to do it either. So that's that. And then let's. I want to try something using some new software here. Let's maybe I can. Will it work? Can I show? Oh, hey, there I am. Okay, so let's look at this. This is a T that I've cut out. It is a T. And so what I want to do is figure out the rotational symmetry of this T. Well, the rotational symmetry of the T, okay, if I pick the center of the T to be the center of rotation, I take this T, you see it? I want to know how far I can rotate it until it's exactly in this position. This length has got to be the same as this bottom length. So I'm going to spin it, all the way around until, oh, click, I think there I've got the same position, right? And I keep looking down. Let me look at the camera. I'm good at this. Okay. And if you think about it, started at the top, went all the way around. The top became the bottom. That's 180 degree rotation. So this has rotational symmetry, 180 degrees. Now if I kept going, round, I end up back at the beginning. So there's only one, it's 180 degrees. So that's how you've got to think about this. If this T was drawn on the picture, on paper, then you would want to, you know, kind of imagine if I could pick that thing up and spin it around, could I ever get it to land back on itself? And that's what you're going for there. And that's it for 9.6. Hopefully you found it fairly straightforward and not too confusing.